Looking at part 3, enter the 10 ohm resistor. It says on the diagram below we're going to draw the schematic and equipment diagrams for the following circuit. Okay? It has 2 batteries in series with a single light bulb and a 10 ohm resistor with an ammeter to measure the current. Okay? So we always start at the what? At the source. Yeah, the batteries. Okay? Yeah, I'm here to pump you up. Oops, I'm too excited. I can't even draw straight. Again, that's why I use a pencil. Okay? Yeah. Hello. I'm Reed. Circuit pumpinator, I'm here to pump you up. Okay, so the first battery pumps it up to 1.5 volts ideally. Second battery should get it up to 3 volts, right? And then I like to draw this like a gravitational analogy. So I like to draw it so the batteries point out. I noticed in my other class, somebody didn't like to draw it that way. They like the batteries pointing sideways or down. You can do that, but if you get confused, that's your problem. I'm going to do it like this. This is less confusing, okay? But hey, free country, right? Anyhow, next we got what? A light bulb, okay, which is a squiggly to represent the filament with a bulb around it, and then a 10 ohm resistor. You guys remember the symbol for a 10 ohm resistor? Okay, it's a zigzaggedy line for a 10 ohm resistor, okay? That's my resistor, 10 ohm resistor right there, okay? And then we're going to put an ammeter in the circuit to measure the what? The current, the amps, right? And that's our circuit in a nutshell in terms of what's going on. Okay. Next, remember our other trick? Okay. Before we do that, we need to label all of the what? The negatives and positives in our circuit. This is a very important step because if you don't label this, chances are you probably will not know how to actually wire it up, because this literally tells you where each wire is going to go from element to element. Okay? And when we label the positive, negative end of each of these elements, what we're trying to say is, well, which end is at a higher potential, which end is at a lower potential, okay? Not to say that one of these elements is more positive on one end and more negative, but which one is at a higher electric potential, higher on that electrical hill, okay? Here's another way to this is a way to visualize this. Later on, you guys are going to do this lab with the computer here, okay? And what's going on here is we have a virtual circuit board. So in every circuit, you got to have a what? A battery as a source of energy, and then we use wires to connect them. By the way, why are we using 2 batteries, guys? Because one battery is only a wussy, how much? Like 1.5 volts, right? So 2 batteries will actually give us what? Like 3 volts here, okay? I think in this simulation they're actually 9-volt batteries, right? Okay? And as we make our connections end to end, okay, we're going to look at then how we finish our circuit here, right? So then we put in our light bulb. And in real life, the way a light bulb is connected, it's actually through the tip and on the side, okay? But what's nice about your circuit board is as you screw it into the socket, it makes those connections for you onto the circuit board, right? And what's different about this circuit now? We're adding in a what? A resistor. Bingo, okay? And then here's the tricky part. An ammeter is always connected how? In series or in parallel? In series because the current has to flow through it, okay? And here's what's cool. Once we complete the circuit, woo, you light up my life, bam, okay? The current can flow. Now you're saying, well, wait a second. It looks like the current's flowing backwards, Mr. Lau, okay? And that's because this one is trying to show you how the electrons move. But technically, we define conventional current as a flow of what? Positive charge, okay? Yeah, so this is uphill and this is downhill. So why is this important? Well, if I want to measure, let's say, the voltage of my batteries, okay, I have to tell the red probe to be on the positive end and the black probe to be on the negative end. So I need to know which end is uphill and which end is downhill. If I get it backwards, what's going to happen? It's going to read what? Negative, that's all, okay? So literally we want to visualize what's uphill and what's downhill, okay? And that's a way to picture what's going on. Think of the pumpinator analogy. Ah, I'm here to pump you up. Back to our equipment diagram. Now what we want to do is translate this really abstract schematic diagram right here. Here's our schematic into our equipment diagram, okay? And so literally you want to trace the flow of charge. So we always start where, guys? We always start with the batteries, okay? So let's call this one battery number 1, this one battery number 2, okay? This is 1 and 2 on my circuit board. The positive is connected where? On the left spring clip, right? Where's the negative one connected? On the right little spring clip, okay? So let's make this black to be consistent. Oh, I don't know why this isn't letting me change colors. Hold on a second. Technical difficulty. Now here's what's a little tricky is we need to add in this time into our circuit a what? A resistor, okay? And the way you're going to connect the resistor is actually in this bottom part of the circuit board, where there's these spring clips that are at right angles to each other. Okay? And the way it's going to work is you can actually slide a resistor into these springs. Okay? Just like that. It'll slide right into there. Okay? And let me show you a picture. When you connect your resistor, you're just going to slide it right into these spring clips on your circuit board. And then to connect, you can slide a wire right into the spring clip in the same one or in the corner, because those corner ones are connected. Okay? And that's how a resistor is connected, to make your life easier. Can you guys see that? Okay. We're going to feed all the wires in now. We start off the source. So pretend you are a little tiny charge here. Hello, I'm a little tiny charge. Okay? And we're going to start here at 0 volts. What's the first thing you go through? You go through battery number 1, right? And now what? From the positive of battery 1, we go to where? The negative of battery 2. So how do you do that? You literally just feed a wire from positive to negative, right? Just right here. From positive to negative. Oh, there we go. Okay? Now what? Let's continue the trace of charge flow. We go through battery number 2. Battery number 2, right? And now what? We connect to the positive end of what? Our what? Our light bulb. So literally we're just going to trace that charge flow, right? So we're just going to feed a wire just like that. Okay? Now what? We flow through the light bulb, and we're going to go to the what? To the positive end of the resistor, okay? From the negative end of the light bulb. So I'm just going to go ahead and go like that. And you know what? Technically, it doesn't matter which end is positive, but guess what? Because I connected this end first, I just made this the positive end. So what's the other end got to be then? The negative end, because then the current will then flow through my resistor, right? And it's now going to go to my what? My ammeter. So you see, literally, what you draw is what you build. It's very tempting to be like, man, Mr. Lau, this is pain. There's all these little details. I don't want to draw stuff. I just want to space out and take wires all over the place. So we want to hook up our ammeter, right? So how do you make an ammeter out of your multimeter? What do you got to do? You got to take your dial and turn it to which quadrant, guys? Remember? Okay, yeah, to quadrant 2, to the 10 amp setting. And then the black plug always goes in what? COM, right? The negative end. But what about the red plug? You got to pull it out and stick it where? Okay, you got to stick it into the 10 amp setting on the right hand side, right? Okay, or left hand side, depending on how your meter's built, right? Okay, and then what goes where? Well, from the negative end of my resistor, I'm going to go to what? The positive end of my multimeter. And then from the negative end of my meter, I'm going to go where? All the way back to the what? Trace the charge flow. We're going to go all the way back to the negative end of battery number what? Number 1. And when you do that, you'll get a reading in amps. You see that? So literally, you build what you draw. And that'll give you success. If you can draw it, you can build it. Okay? And that's the secret to adding in a